Okay, so I'm going to go over this review with you and make sure you know what's going on. So the first one says to graph the function and describe the transformation. Whenever it says to describe the transformation, you just write what it's doing, where it's moving, any flipping, any stretching, whatever. So you look at the equation, and this minus 3 is on the outside of the function. So whenever you have something on the outside, it moves up or down, and so this is going to move down 3. And that's all it's going to do. It's not going to move left or right. It's just going to move down 3. So we put our vertex down 3, and then we follow the quadratic, it's a standard quadratic pattern. There's no shift. So that goes up 1 over 1, then up 3, and over 1, gets mirrored on the other side. So there is your quadratic graph. Number 2 says what's the vertex and direction of opening, and number 3 says the same thing. So the vertex it's a quadratic again, you have the square. The vertex is that point in the middle of the parabola. So this is a vertex for that graph. So where will the vertex be depends on the movement. So the plus 4 inside, the minus 2 outside tells you it's going to move left 4 and down 2. So at what point would that be if you move left 4, and down 2? So just go look at the graph, and 1, 2, 3, 4 left, down 2. There's where the new vertex is going to be. So that point is negative 4, comma, negative 2. So there's the vertex. The direction of opening is simply either up or down, and it's going to be down because it's getting flipped upside down. So the direction of opening is down. Okay, number 3, same idea. There is nothing added inside with the x, so there's no left or right shift, but there is a shift up, so the vertex is just going to be 0, comma 1. Direction of opening, now the 8 is positive, so it's going to go up. So numbers 4 and 5 say to describe the transformation and then graph the function. So again, you're just looking where is it moving, where is it shifting. Inside shifts left and right, and it's opposite, so negative 2 is going to make it go to the right 2. So just say that, shifts right 2. And there's nothing else. There's nothing added outside, and there's nothing in front, so that's it. It shifts to the right 2. Then you draw the standard quadratic pattern. So up 1, right 1, up 3, right 1, and mirror it on the other side. And there you go. Number 5, you've got an absolute value. So where's the shift go? First of all, so it's shifting to the left 2, and it's shifting down 3. And then that minus in front says it's going to flip upside down. Okay, so we go left 2, down 3, put our vertex, and then this is an absolute value because you got the bars on it. So instead of going up 1, right 1, you're going to go down 1, right 1, and mirror that on the other side. And there's your absolute value graph. Number 6 is asking you to classify each of those. So you just name it based on the picture. So the first one is a square root, and so you just write square root. The second one is a quadratic. It's got that quadratic shape. The third one is a linear. It's got a line. The fourth one, absolute value. And the fifth one is an exponential because it's flat there at the bottom, and then it's going up very quickly. So number 7 and 8 tell you to graph the function and then state the domain and range. So both of these are square root graphs, and just like before, you're thinking, what's the shift? So this is going to move to the right 2, and then that's it. There's no up or down, there's no stretch, so you just move it to the right 2 and put your dot on there, and then do the square root pattern. So it goes up 1, right 1, and then up 1, and then right 3. So if you notice, that is very much like the quadratic, it's just flipped. The quadratic goes up 3 and right 1 instead of up 1 and right 3. Because the quadratic and square roots are inverses. But then we need to state the domain and range. So there's two ways you can write the domain and range. First way, write domain, and then domain is all the x values. So you look at your graph, and it starts at x equals 2, and then it goes to the right. So you're going to say it goes from 2 to infinity. And you write it like that with a bracket on the 2 and a parenthesis on the infinity. Then the range goes from where to where? Well, the lowest y value is 0, and it's going to go up forever. So it starts at 0 and it goes to infinity. So that's one way to write domain and range. The other way, the domain would be x is bigger or equal to 2. So then the range would be y is bigger than or equal to 0. So both of these are good ways to write it. You can write it like this. You can write it like that. They both say the same thing. Okay, number 8. We have this plus 3 inside. It's going to move it to the left 3. And this minus 1 outside is going to move it down 1. Okay, so your end point is going to go left 3, down 1. And then you can draw your shape from there. You go up 1, right 1, up 1, and right 3 more. And there's your square root graph. And then domain and range. So the domain is all the x values, starts at -3 and goes to the right. So it goes from -3 to infinity. And the range starts at -1 and goes to infinity. Okay, number 9 is talking about a piecewise function. Whenever you're graphing piecewise functions, the most important spot is the boundary. So this line where they're separated, okay, all of them are at 50, right? So there's no difference there, but there is a difference in the dots, the open and closed dots, and which line is on top of which line. So let's read through here. It says a store charges 70 cents per pound for less than 50 pounds. So that means that exactly 50 pounds is not included in the 70 cents. Okay, so your open circle is going to be at the end of this line. And 45 cents per pound for 50 or more pounds. So the 50 is going to be included in the second line because it says 50 or more. So the solid dot needs to be on the second line. So the first line should have an open circle, and the second line should have a closed. So A fits that. C, first line is open, second line is closed. C fits that. B, first line is closed, second line is open. So B gets eliminated because of that. And then D, same way. The first line is closed, second line is open. So D gets eliminated. And then you just think, well, the discount, right? You're getting charged less when you buy 50 pounds. So if you bought just a little bit less than 50 pounds, you would be charged more than if you bought exactly 50 pounds. So the first line should be above the second line. Right? So A fits that. The first line is above the second line. Okay. C is saying that you're getting charged more for 50 pounds than you would for 49 pounds. So it can't be C. It's got to be A. So that's what I would do for those. Just use elimination to figure out what it can't be and then what it has to be. All right, number 10 is asking about the x-intercept. Whenever you're looking at intercepts, you're going to plug in zeros. So you can plug in 0 for y when you look for the x-intercept, plug in 0 for x when you're looking for the y. So you plug in 0 and then solve for the other one. So if I put a 0 for y and then solve this for x. So in order to solve this for x, I need to get rid of the square root. So I'm going to square both sides, and that's going to get rid of the square root. Squares and square roots cancel each other out. So we have negative 2x minus 3 on the inside equals 0 squared. 0 times 0, so 0. And then you just solve this simple equation for x. So you're going to add 3. And then we have 3 equals negative 2x. Divide by negative 2. And there's our answer. So x equals negative 3 over 2. All right, make sure you go over that review. And if you have questions, make sure you ask before the test on Thursday.